So the outermost ring is referred to as the valence shell of electrons. Let me draw elements in the second period now. Let's go with 2 shells, okay? Second period. So if we look at the periodic table, let's draw beryllium, okay? So here, I'm going to draw my little nucleus. What is the atomic number of beryllium? 4. So we're going to put a 4 plus. Now, in that first electron shell, because we always fill up the first one, how many electrons can I put in there, Anuya? How many electrons can I put in the first shell? 2. Okay, maximum in that first shell, 2. Okay, so here's my question. I need to put how many electrons total in a beryllium atom? I need to put 4 electrons in a beryllium atom. I've only placed 2 so far. I'm missing 2. What do? I make another shell, the second shell. Okay? How many electrons can I put in this shell? What is the max number in this shell? The max number is 8, but how many do I need? I only need 2 to get my total of 4, correct? That is a Bohr-Rutherford model for beryllium. Now, which one is the valence shell here? I have my first electron shell and I have my second electron shell. So Anuya, which one is the valence shell? The outermost shell, the last one. In this case, it's the second shell. So this is my valence shell. Now, let's draw aluminum in the same period. Okay, so what is the atomic number of aluminum?
13.
So I'm going to draw my little nucleus. 13 plus. That means I got to put how many electrons?
13.
13. Okay, so first orbit has how many? 2. Awesome. How many am I missing? 11. Okay. Oh, actually, no. Oops, shouldn't be doing this. Sorry, we're going to go with oxygen instead because we need something in the second period. My fault. Now, here's my second period. I have 6 electrons to place, right? What is the max number I can place? 8. So 1, 2, 3, 4, 5, 6. How many valence electrons does oxygen have? It has 6 valence electrons because the valence shell is the outermost shell. Okay, so this is the valence shell, which means that it has 6 valence electrons. And E negative means electron, okay? Now we're going to look at something on the third period. So we're going to take our good friend, Mr. Sodium. Okay, what is sodium's atomic number? So let's go with our little circle here, 11 plus. Now, first electron shell has how many? 2. First of all, how many electron shells do you think sodium is going to need?
3.
It's going to need 3 because it's in the third period. So I'm just going to, bite the bullet and draw all 3 here. Okay? Notice how I gave myself more room because I knew it would be bigger. So, first orbit, first electron shell, how many?
2.
1, 2. Second?
8.
Okay, so that's a total of what so far? 1, 2, 3, 4, 5, 6, 7, 8. I'm missing how many?
1.
I am missing that lone little guy on my outermost shell. So this guy is going to have a valence number of 1. If you look at your periodic table, you will notice that sodium is in group 1, Roman numeral 1. The Roman numerals at the top of the columns, at the top of the groups, identify how many valence electrons are in that group. You don't even have to figure this out. You just have to know how to read your table. Okay? Now, here's where it gets kind of tricky. If I look at chlorine, which is in the same period, okay? If I look at chlorine, what is chlorine's atomic number?
17.
So, we've got our little circle here, 17. Now, how many shells? I'm just going to draw those 3 shells out. And here's where it gets interesting. I'm just going to place my electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So how many valence electrons do I have here?
7.
I have 7 valence electrons, okay? And if you look at chlorine, chlorine is in group 17. Look at the Roman numeral above that column. 7. All right? Now, if we look at something in the 4th period, okay? If we look at something like bromine, all right? Bromine is going to have more than 8 electrons on its last shell, right? It still has a maximum number of 18, correct? So if I draw bromine out here, bromine's going to look a little different, okay? So what's bromine's atomic number?
35.
Ay. Okay, and don't forget your plus sign. This is going to be quasi. 1, 2, 3, and 4. Now, I'm just going to pause this and draw these in. 1 through 8a, what is the highest Roman numeral that you get? It's going to be in group 18. What's the Roman numeral there? Roman numeral of 8. You can only have a maximum of 8 valence electrons. What? There's 17 valence electrons here. So what ends up happening, in order for chemists to explain this, okay, what ends up happening is these electrons get excited, okay, and what we say is this little imaginary energy shell pops up on the outskirts, and the 7 electrons hang out on that imaginary shell. They cannot stay there forever. They come back down to their regular shells. But electrons have the ability, when something gets excited, okay, so like when a substance is heated, electrons and particles move more. Those electrons will get pushed to the outer imaginary shell. But they can't maintain that amount of energy forever. They will eventually come back to their original shell. So just because bromine has 17 electrons on its outermost shell, if you look at the periodic table, it is in group 17, but it is in the valence electron group of 7. Therefore, it will have 7 valence electrons. How many is it missing to fill that outermost shell? What's the maximum number you can get in the outermost shell of valence electrons? 8, right? You can only have 8 valence electrons. There's only one group of elements that has full valence electrons. What group is that? Look in your periodic table.